All right, just give a little perspective on what I think physics is and how it fits into different things. At the basis, the very bottom, place mathematics. Mathematics is the way to organize our thinking. Mathematics is the language to express our ideas. Um, Off from mathematics, you could apply that in computer science. You could apply mathematics, at least those parts of mathematics that have a role in the natural world, as physics. And then applying physics, you have a myriad of sciences, some of which are astronomy, my own home sweet home, geology, chemistry, atmospheric science, oceanography. All of those are applied physics. And then, at least in my own way of thinking of things, biology is the application of chemistry to those subset of reactions that are self-sustaining and we recognize as life. That's my little 2 cents for how the sciences fit together, and the role of physics within that is this central element of trying to understand how things in the universe work in a mathematical sense, in a concrete sense. All right. So, at least in my own telling of things, physics is the most basic of the sciences. You tend to be concerned with very simple ideas like what is motion, what is energy, and it's a fundamental science in that sense. You want to go from uh, a deep understanding of simple things to then go out and address complexity. We tend to have a value for the simplest explanation for a natural phenomena. Uh, so Occam's razor is very important in physics. And then, at least from my own point of view, the other sciences are applications of physics. At least they should be, in as much as possible. The role of mathematics is the language of science. And a good deal of what has been developed as mathematics, for example, calculus, um, was creation motivated by physics, and that dual relationship between mathematics and physics, perhaps not as strong and tightly coupled today as it had been in the past, but there's a very strong motivation in mathematics to have things that are applied in the natural world, and physicists are very concerned with the mathematics that they need to describe nature. Some things are relatively straightforward, and some things are very, very difficult. And to this very day, there are but a handful of solutions to Einstein's field equations. So, what is physics? Like all of the sciences, physics is about the interplay between theory and experiment, or speaking for myself as an astronomer, observation. So, observational science as well, not just experimental. And this is crucial because we can all be fooled. We can all make mistakes, think we have a right answer because it appeals to our aesthetics, or it's a nice answer, it's a clever answer. But it doesn't really matter what we think. What matters is what we observe. What matters is what we find from experiment. That's the important part. That's what makes the scientific method work. We have an arbiter, nature. What does nature say through experiment? And we'll give a few examples over the course of this semester, but basically name any famous physicist you want, Feynman, Einstein, Galileo, all horribly, horribly, horrendously wrong about some things. in their work. That's part of the nature of the work. And what keeps us from going way off track and doing things just horrendously wrong all the time is that we have experiment. Another way to look at that, the fact that even Einstein has made mistakes, is it's okay to make mistakes. You're going to make mistakes. I'm going to make mistakes. Everybody's going to make mistakes. What we hope to attain is that we can recognize when we've made a mistake, learn how to correct our mistakes, and think through things. All right. Some possible motivations for studying physics. It is the foundation of all the natural sciences, as I've said. A lot of technologies have arisen by applying physics. The laser is a multi-billion-dollar industry. Giant magnetic resistance gave rise to a great shrinking of the size of a bit of information stored on a magnetic platter. We don't necessarily know that an idea is going to give birth to an entire field of technology, but time and time again, ideas from physics that may seem very abstract at first have turned out to be very, very useful in technology. There are lots of cases in whatever field you happen to be interested in that applying mathematics to analyze a situation can be beneficial, can give you crucial information. We face a lot of issues that are rooted in science. The arguments about what to do or the existence of a problem itself are based in scientific arguments. So at some level, every person, every voting citizen needs to have some degree of scientific literacy to live in our complex modern world responsibly. And it's an argument that goes back to Richard Feynman. There is an additional beauty that can be found by understanding the physics of a phenomena. So not just seeing the phenomena, experiencing the phenomena, but understanding why it happens, how it happens, can add an additional sense of wonder to what you experience about the world around you. Hopefully, over the course of the course, that was awkward, over the course of this class, you'll have many examples where, gee, that's nifty to know that's how that works. That's one of the best aspects of physics, in my own humble opinion.